Alright, so today we're going to be learning about using tree diagrams to represent a sample space and to calculate probabilities. So we'll talk more about tree diagrams exactly when we actually look at an example, but first I want to talk about a keyword, sample space. So sample space, we'll just write it out. I'll write the definition here, is all of the possible outcomes. So sample space is another phrase for all the possible outcomes. So we're going to look at an example. Let's say a family is going to have two kids separately, two kids. Currently they have 0. We know that they won't have twins. One question we could ask is, what's the probability of having two girls? Or having both girls? I guess two girls or both girls. The way we could figure this out is to kind of represent it out with a tree diagram. So with the tree diagram, what we could do is we can list out first the stages. So the first stage in this scenario is this family or this couple will have one kid, right? They have a first kid. So we write out the first kid. That's like stage 1. What are the possible outcomes of that first baby? It could either be a boy or it could be a girl, right? Then what we could do is list the second stage, because in this problem there's 2 stages because they're having 2 kids. So the second stage, and what we could do there is we draw a tree diagram. This is why it's called a tree diagram, because we'll draw branches from the first stage. So what we do is thinking that what if they have a boy first, the possibility or the possible outcomes of the second one would be also a boy or a girl. But more possible outcomes would be, what if the first one was a girl already? They could have a boy the second time, or they could have another girl, right? So after we listed the 2 stages, we list out the possible outcomes here. So the way we could kind of look at how many possible outcomes there are is, we look at this. This is one outcome, right? Is they have a boy first and then a boy again. Or they can have a boy first and then second they can have a girl. Or they can have a girl first and then a boy third, or a boy after that. So that's the third outcome. The last outcome is if they have a girl and then a girl. So what we could do under outcomes is we'll list that out. That's one outcome. B represents boy, G represents girl. So one outcome is having back-to-back boys. Another outcome would be boy and then girl. Another outcome would be girl then boy. Lastly, it would be girl then girl. So what we did was we right here, this is our sample space. Remember we said sample space is all the possible outcomes. These are the 4 possible outcomes of genders when you're having 2 kids. What we want to do here, though, is they want us to figure out what's the probability of having 2 girls. So let's see. So we're looking at this. What's the probability of this? So what we could do here is, actually going back to the very beginning, right here. This is what we started with. What's the probability that you have a boy? All right. We're going to write down the probabilities in each section here, and that'll help us figure out the probability of each outcome. So let's take a step back. So what we need to know is that the probability of a boy having a boy or a girl, it's 50-50, right? So it's 50%. So we always write it as a decimal, but we're gonna do some calculations with it. So we put 0.5 there. What's the probability of having a boy in the second? What's the probability right here of having this one, the second kid, be a boy? It's also 50%, or 0.5. What's the probability of the second child being a girl? Again, 50%, or 0.5. And you notice it's the same for all of them. Because remember, if you're having a kid, if your first one, you have a first kid, it's 100% chance it's either going to be a boy or a girl. That's why you add 0.5 and 0.5, you get one whole, which is 100%. So a 50% chance. And then that works the same way for this over here. So key point there is just to know that when you're having a kid, it's a 50% chance that it's going to be a boy or a girl. 0.5 for a boy and 0.5 for a girl. That's why all of these are 0.5. I'll look at another example after this where it's not exactly even. Okay, so looking at the outcomes, to figure out the probability of having both boys, there's a really simple thing you can do here. All you do is you just multiply the two branches together. Right, the boy, so you circle the two boys. Or you don't have to circle it, but visually know that you're doing that. So now you multiply the 0.5 with the 0.5. So let's do that over here. We'll do 0.5 times 0.5. That'll get you 0.25, which is 25%. And then you would go on to do the other ones. Let's say if I want to figure out the probability of having a boy and then a girl, you look at boy and then girl right here. Do the same thing. You multiply it 0.5 times 0.5. And it also gets you 0.25. And if you notice, we're actually going to get 0.25 for all of them, because all the probabilities here are 0.5. So right here, to figure out girl, boy, we're doing 0.5 times 0.5 also, right? So this one's a pretty simple one because it's the same for all of them, because you're always going to be multiplying 0.5 times 0.5, and that'll get you 0.25 or 25% for each of them. So right here, now we can look back at the question. What's the probability of having two girls? There's there's 4 possible outcomes, right? Right there, 4. And only one of them comes up as having 2 girls, and that's that last one. And what's the probability? 0.25, right? How about this question I want you guys to think about? What's the probability of having one boy and one girl? We don't care about the order. We're just figure out what's the probability of having one boy and one girl. Let me just fix this over here. So looking at the 4 outcomes again, how many of those outcomes has one boy and one girl? The second one does right here, and this third one, right? Both those probabilities both those outcomes fits the scenario of having one boy and one girl. So to figure out the probability of having one boy and one girl, we don't care about the order. We just add those 2 probabilities together, 0.25 and 0.25, and that'll get you 0.50, which is 50%. Right? So let's see. All right, so I'm going to come with another example, a little more complex. So imagine a bag has, let's say, has 3 Skittles and 2 M&Ms, right? So I'm going to say we will pick a candy at random twice. One thing I'm not gonna write it, but one thing I want you to just know here is after we pick out the first candy, we're gonna put it back in. So it's like you're starting over. So we pick a candy twice at random. We're gonna list all the possible outcomes. And their probabilities. So how likely each thing will happen. So here, we're gonna do the same thing. We're gonna do tree diagram. We list the stages again. First stage would be first candy, because you're picking candy twice, right? Or let's see, first selection. Put that over here a little further to the left, and then second selection, and then outcome. I want you guys to know that, let's say if this problem happens where you pick a candy at random 3 times, then that means you have 3 stages. This would instead be the third selection. So it could go on and on. But in this problem, it's only 2 times is where you're picking candies. So there's only 2 stages. First selection, second selection, and then the outcome. So the first selection, what's a possible outcome? First thing you could do is you could grab a Skittle, right? Or you can grab an M&M. The second thing that could happen is, or one thing that happens is, what if you grab a Skittle first? The second thing that could happen is you grab an M&M second. Or you grab a Skittle first, and then instead you grab a Skittle again. But then what if now you grab an M&M first? What could happen from there? If you grab an M&M first, you could grab another M&M, or you could grab a Skittle. So just like in the other problem, there are how many outcomes here? 1, let me highlight it. 1, 2, 3, 4, right? So the first outcome would be you grab Skittle, then you grab M&M. Or you could grab a Skittle, then a Skittle. Or you grab a M&M and an M&M. Or lastly, you could grab an M&M and then a Skittle. Those are 4 possible outcomes. But here, we're gonna list the probabilities, all right? We're not gonna put 0.5 as the probability of grabbing a Skittle. And the other one is a 50-50 chance of having a boy or a girl, because it's even. But if you look in the bag, there's 3 Skittles and 2 M&Ms. So the probability of grabbing a Skittle, there's 3 Skittles out of how many total candies? There's 5, right? 3 Skittles plus 2 M&Ms makes 5. So it's 3 out of 5 chance that you grab a Skittle. If you guys divide 3 divided by 5, you get 60, or you get 0.6. That means there's a 60% chance you get a Skittle. But we use 0.6. But what's the probability of getting an M&M? There's 2 M&Ms out of 5 total candies. So 2 divided by 5, that'll get you 0.4. And again, if you notice, there's a 100% chance you're going to get either a Skittle or an M&M, because it's proven here, you do 0.6 plus 0.4, that'll get you 100%. So what we could do there, keep going. As we mentioned earlier, the probability of grabbing an M&M is 0.4, so you put 0.4 for M&M. So again, for all the M's, you could put 0.4 because there's a 40% chance of grabbing an M&M. And for all the S's, you could put 0.6 because there's a 0.6 chance of getting a Skittle. So if I want to figure out the probability of grabbing a Skittle and then an M&M, all I do is you multiply the probability of that branch right there. 0.6 times 0.4. And that'll get you 0.24. So that's a 24% chance that you're going to grab a Skittle first and then an M&M. And let's look at the other ones. What's the probability of grabbing a Skittle first and then a Skittle second? Here we just multiply the probability of Skittle, which is 0.6, times the probability of getting another Skittle, which is 0.6 also. So we do 0.6 times 0.6 there. And that'll get you 0.36. And we could keep going so on with the other parts. Let's just finish this off. So the probability of grabbing 2 M&Ms, you multiply the probability of M&M first, and then the other probability of M&M. So 0.4 times 0.4, that'll get you 0.16. And then lastly, for M&M and then Skittle, you multiply 0.4 times 0.6. And you get 0.24 like we did above. And what I want you to notice again, if you add all these probabilities down here, you should get 1 whole or 100%. And also you notice that the most likely thing to happen is grabbing 2 Skittles, right? SS, which is 0.36 because there's more Skittles than M&Ms in the bag. And the least likely thing to happen is grabbing 2 M&Ms, which is 0.16 because there's fewer M&Ms than Skittles. So hopefully this is will help you understand tree diagrams and writing the probabilities for them.